Hi and welcome back to a new video. Today we will test the ProSiphon Elite from Ice Giant. Most of you will probably already have seen this cooler and are familiar with this one, especially after the Linus Tech Tips review, which was a very good video and went quite viral, I think about a year ago. So that's a quite unique cooler, and it's not entirely new, but it's close to being something very innovative. Actually, let me grab a heat pipe cooler for comparison. Okay, so we have this Noctua NHD15 heat pipe cooler, which is really a classic PC cooling unit. I think this has been around for like 10 years, and over the past decade, it's still a great cooler. I can absolutely recommend this to the day. It's still a great unit. And as you all know, it's just a typical heat pipe cooler. So we have the contact surface on the bottom, which makes contact with your CPU, with your heat source. And then the heat will be transported over the heat pipes to the fins on the side. And the heat pipes, I mean, I'm 99% sure that 99% of you will be familiar with how a heat pipe works. That it's a very simple copper pipe with some wick inside the copper pipe, which will transfer our fluid. And the way it works is that the copper heat pipe is just sealed off and you have a tiny drop of fluid inside. Could be water. Usually it is water in our heat pipes we're using for PCs, and then they're decreasing the internal pressure of the heat pipe, maybe to like 10 millibar, and in that region you will have a evaporation temperature of your water of about the ambient temperature we have right here of like 20 degrees Celsius. So if we apply any kind of heat to our contact surface on the bottom, it will transfer the heat to the heat pipes. We have this tiny amount of fluid inside, it will evaporate, and it will go to the area which is colder, which is sitting up here in the fins. Eventually will evaporate and go back down inside the heat pipe following the wick which is inside the heat pipe. That is the basic way of how a heat pipe works. And it's very simple, it's very cost efficient, and they can transfer a very, very high amount of heat. The only downside is that you have to know your exact operating conditions. So for example, I mean, Noctua will have like, I don't know, like 20 to 80 degree operating temperature, for example. And then this way you will select your diameter of your heat pipe, your fluid which will sit inside, your internal pressure and everything. But if you know your operating conditions, which is something we have in our PC, then this is a very, very efficient system. The only issue you will ever or you could ever have with heat pipes is if you're exceeding those specs. So for example, you're trying to overclock 11900K at 1.5 volt, 5.3 gigahertz in Cinebench, and you will have a heat output of like 400 watt. That is like the only scenario where you would have issues with the heat pipe, because if the heat output is too high for the heat pipe and the thermal difference or like the temperature difference between of our hot and cold point is too close to each other, then at a certain point the heat transfer will simply stop, because you need the temperature difference for the heat transport to work. And that is the reason or the region where you could use the thermal siphon, the ProSiphon. It's not really a thermal siphon though. I have to make that clear, because I saw that in other videos, like other YouTube titles, that this is a thermal siphon. Thermal siphon. It is not. It is a two-phase thermal siphon, which is much closer to a heat pipe than you would think. Because a normal thermal siphon, you can just imagine a bucket of water where you're heating the bottom, and due to the change of density in the water, because the warmer water on the bottom will have a lower density than the cold water, which means that the warm water will just float on top of the cold water. It's very simple. That is how you can have a circulation within, if you have just one huge pile of water and you heat it up at a certain source, because of the density difference in the temperature difference, you will create some kind of circulation without any pump or anything. And that is a thermal siphon. But it's not really the case of this unit, because it still uses evaporation, which makes it being closer to a heat pipe than an actual thermal siphon. So it is just a massive heat pipe, to make it very simple, but it doesn't use the wick inside. It relies on gravity. So that is what probably takes this apart from the normal heat pipe cooler, is that it's basically a massive heat pipe without a wick inside. So if you heat up the cold plate on the bottom, it will also probably use water, just a much higher amount of water, and it will rely on gravity. So if you heat this up, then you will have evaporation of the water and the gas will spread over here in the area of the fins. It will condense and drop back down. It's very simple. And that should actually help in a region where a heat pipe cooler is in the area of saturation. And that is the idea. I never tested the final unit so far. I had a very, very early prototype back then with the first generation of Threadripper, which was very promising, and the final unit, at least in some of the reviews, looked also very promising, at least at very high heat outputs. But whenever the heat output is low, so for example, just during a normal gaming scenario, especially if you're just using like an AMD desktop CPU, and your AMD CPU will maybe have a power consumption of like 60 watt, that should be the region where any like normal heat pipe cooler or AIO should be superior to our thermosiphon. Okay, but enough talking, let's just start. We will start our testing with the Corsair H150i AIO, simply because I still have this set up from a Corsair overclocking guide I did, just for the first comparison values and also to let you know how I plan to do the testing. Our long-term partner Hetzner has a special offer for this month if you are looking for a dedicated root server of the AX NVMe series. The AMD Ryzen CPU-based server with Zen 2 architecture will have no setup costs, which saves you up to €105. The offer is valid for AX41, AX51 and AX61 servers, which come with up to 128GB of memory and, depending on the configuration, dual 512GB NVMe SSDs or dual 2TB NVMe drives, which can be further expanded if necessary. The Hetzner servers are based in Finland and Germany, and as usual you will have all amenities like fast internet connection and no minimum contract period. Find out more in the link below. For the test I pushed the 11700K to 5 GHz 1.3 volt V-Core, which equals a power consumption or a load of about 240 to 250 watt, which I think is quite realistic. And I had a warm-up phase of about 10 minutes, and I'm just going to reset this and run our test phase for another 5 minutes. And for the test phase we're going to record the average core temperature across all the cores for 5 minutes. If we now take the average of the average over our testing period of 5 minutes, we have a result of 84.4 degrees Celsius on the core, while we had a load of 243 watt on average. I repeated the same testing in a gaming scenario, and again we had a heat up phase of 10 minutes followed by a testing phase of 5 minutes. The average power draw during the test phase was 112 watt, and the average of the average temperature was 53.2 degrees Celsius. My 11700K is far from being a golden sample. It's just a random retail CPU I bought. You can see in idle the voltage is 1.5 volt for 5.1 GHz. It will drop down quite significantly due to the load line calibration. It will drop to 1.43 roughly. Yeah, but it's straight in a region where the CPU will start throttling, as you can see. So 5.0 GHz works, because I can use like 1.37, 1.38, something in that direction. But I cannot run 5.1 simply because I'm reaching the thermal limit of the CPU and it will just result in throttling. So that is the point where I'm wondering if I would use this cooler for like my overclocking attempts and stuff, if I can get further than using like an AIO or even the NHD15. By the way, if we just grab this and place it right here, just for like size comparison reasons, you can straight notice that the ProSiphon is quite a bit bigger than the NHD15. And that's also something I'm always, or I have been wondering about when I saw the reviews of the ProSiphon. If you would extend this in size, like make it wider, like if Noctua would decide to just make a massive air cooler with 2 more heat pipes or whatever, if they somehow fit them in here, if they would reach the same type of like cooling capacity as the ProSiphon Elite, but I cannot really judge because I really have not tested this yet. That's what I'm going to do. By the way, that's something that's also very important. This is nickel plated copper and this is aluminum. For whatever reason during the manufacturing process, I mean they have to seal this off after they filled it. So that's maybe a bit more difficult, but I also remember that they told me they were working on a like full copper version. Would be very interested in seeing that. But I just wanted to highlight this because you can use this one with liquid metal, but you must not use this one with liquid metal or it just will simply fall apart. Also wondering, considering the size and weight of this and looking at all of that, how convenient the mounting will be. The mount is super simple. You just have your stainless steel backplate, you add those standoffs, add these covers on the left and right on top, screw this down, and then in the end just add your fans for this side only. Like, point of conflict could be if you use very high memory modules, but I mean those are Vengeance RGB Pro SL Corsair memory sticks. They are already a bit higher, and that's also no problem. Could just be that, yeah, I mean, depending on your case, could definitely collide, depending on your case, obviously. Yeah, so I just already tried it in the German part. I was expecting to, I don't know, see like 5.1 gigahertz constantly, but the result is actually even a bit worse. That is very confusing. I expected this to be amazing and to see 5.1 gigahertz all the time. I was very excited, and now this looks much worse than I thought. Yeah, very strange. I'm going to remove the cooler just to be sure that the contact was there. I'm 100% sure that I peeled off the foil. That will not be the issue because I had it sticking to my arm already. I was already annoyed by that, so yeah, let's check. Contact looks great on both CPU and cooler. I mean, this on the side is just caused by, if you're removing it the cooler, you're moving it a big back and forth, but was not the contact issue. I only started the test 1 minute ago. You can see it on the bottom right here in hardware info. But already now the test results don't look that great. The condition is still the same with just above 200 or just below 250 watt. I will finish the testing, also test the NHD 15, and yeah, let's talk about the results in a second. Reviewing stuff and everything, I mean, that's nice, but you wouldn't be on my channel if you wouldn't try to open up things. In this case, we're missing screws, so it's not going to be that easy, but we can try to cut it open. Yeah, I just figured out that I don't even have a vise on here. I'm still trying to like set everything up in my machining hall right here. CNC is the first machine. We actually have a second machine right there. Cannot show it right now, but you might see it in one of the future videos. But yeah, first gonna mount the vise on the desk and then let's see how it looks inside. I first removed the outer shell, had some screws on left and right, and we have a very, very high fin density. So if you compare this to any other air cooler, this is much denser fins than what you would typically have on any kind of air cooler. Means that it has a very high surface area, but at the same time you need very strong fans to push the air through these. Which also explains why they're using 4 fans, and the Arctic fans are also quite strong when it comes to the air pressure and also the noise level. I mean, those Arctic fans are a great choice when it comes to fans itself, so I'm very happy with that. And then it seems like we have this massive thing in the center. I guess the gas would just go up right here, go through the outer parts, and then it would condense somewhere in here. So I guess we will make the first cut just right through here and take a look inside, and then later go to the bottom part. So on top, we just removed some of those aluminum fins. I'm not sure how exactly they are fitted there. If they're like soldered, welded, I don't know. Yeah. We're assuming that there is just water in there, but it could also be a different kind of fluid. And I mean, I'm not sure if it's like a highly flammable fluid, at least there's no info on that, so yeah, just going to cut it by hand, just to be sure. All right, so one thing we got from this part is that it's overpressure inside, like solid overpressure, which means that it's not possible that water would be inside. Could be some refrigerant, which you could use in like a AC unit maybe. Something which requires pressure to make sure that the boiling point is, I don't know, 30 degrees Celsius. Yeah, at least it was not water. Interesting, so there's just fins inside. I'm not even sure what I expected, but just fins, interesting. At the point where everything was like evaporating, this caused cooling on the plate right here. It's pretty cold, maybe like 10 degrees Celsius, just because the fluid evaporated, which removes the heat. Okay, so last thing, open up the bottom piece, see the condenser and maybe additional structure. It's amazing how soft the aluminium is. Precise like a surgeon, as you can see. But at least we can see some part of the internal structure. It's just fins. Fins, fins, fins everywhere. Also amazing how soft this aluminium alloy is. It's very interesting. I mean, it's much softer than a typical aluminium alloy. And I'm not 100% sure how they manufactured it, because it's like stuck to the bottom and stuck to the top part. Okay. At least in the center part we have some holes, like bigger and smaller holes, which could indicate that this is meant for circulation, because if there's like just water or some kind of fluid heating up, it would rather go up through the bigger holes than the smaller holes. It could also be that the gas would go through here and the liquid comes back down there, something in that direction. Not really spectacular. Yeah, it's just 4 holes essentially. Seems like an aluminium cast part. I mean, it's probably the only way how you can manufacture this. Might also explain why it's so soft. 2 big holes, 2 small ones. Perfect. Guess this will go on eBay slightly used. All right, let's check out our testing results. Our first testing was with Prime 95 12K, just below 250 watt load with the 11700K overclocked. And if we take a look at the results, all 3 coolers basically perform very similar. The Corsair AIO H150i is like 1 degree colder than the NAHD 15, and it's about 3 degrees colder than the ProSiphon Elite. And all those results are normalized when it comes to the room temperature. I recorded the room temperature. For one it was like 26 degrees and for the other one was like 26.6. So I normalized the results to equal out the different ambient temperature, even though it was quite warm ambient temperature. But overall the results are very similar of our 3 coolers. But now if we take a look at the noise level, you will straight see that the H150i can be quite loud. The fans are great, performance-wise it has quite decent pressure, but it also can be very loud, which you can see right here. 52 dBA for the H150i, and both the Ice Giant and Noctua can reach about 47 dBA. And then I thought, let's just normalize the noise level to 42 dBA. I can do it like by roughly plus minus 0.5 dBA. It's not that accurate right here, but it's pretty much measurement tolerance. All of the 3 about 85.5 degrees Celsius. But what about gaming load, which is about half what we tested before with Prime 95. It's a lot less load on the CPU, about 115 watt load. You can straight see that the H150i performs great with about 53 degrees Celsius. I didn't record noise level at that point, but it's about the same as what you can probably not here right now, but as it sits right here on the table, cannot really hear it. It's absolutely not annoying. NHD 15 and ProSiphon Elite about the same with like 57 and 58 degrees Celsius. After going through the desktop performance results, and I mean, you've seen it over the progress that when I tried to really overclock the 11700K, get the most out of it with very high power consumption, the ProSiphon still couldn't handle it, which was actually quite disappointing to me. Because I kind of expected, I'm not sure why I expected this, but I thought if the heat output is very high, then this cooler might be superior to the competition, which it wasn't. But then I also realized or remembered that when the cooler came to the market or when it was developed, it was exclusively developed for AMD Threadripper. Back then, like, I don't know, like 2 or 3 years ago when I had a prototype of this cooler, it only came with AMD Threadripper mounting and it was not supposed to be used with desktop CPUs. So I thought, okay, let's just also do some AMD Threadripper performance analysis. Unfortunately, the NHD 15 cannot be mounted with AMD Threadripper. There are Noctua-based air coolers with a huge mounting plate for the bottom. Unfortunately, I don't have that one here right now, but you have to keep that in mind that there is also like a very good alternative for Noctua with a great cooler base, so just to keep it in mind. All right. To look at the performance, the ProSiphon Elite managed to keep the 3960X, which was overclocked, and the noise was limited to 47 dBA. Power was about 320 watt on load, and the Ice Giant ProSiphon Elite had about 91 degrees Celsius and the H150i about 94 degrees Celsius. So in that very, very specific use case, the ProSiphon was superior to this 320 AIO, which is probably mainly related to the contact surface of the CPU. I mean, this AIO is also specifically not built for Threadripper. There are Threadripper built AIOs and they might also perform better in our results. So just keep that in mind. But in that very specific use case, and that's, I mean, the cooler was designed for this, it's performing good. It's absolutely performing good, and I guess for the price, it would be a good choice if you are using a Threadripper CPU and if you're also overclocking the Threadripper CPU, because I'm also quite confident if you don't overclock the CPU and the power output is lower, maybe like 150 to 200 watt, it might be equal, or the ProSiphon might even be worse performance-wise. That's something you have to keep in mind. So that's, to me, that's the only use case what you can use the ProSiphon Elite for. I mean, that's a very specific use case, but in that one, it performs great. For desktop, I have huge hope for the copper version, because when I showed my results to Ice Giant and just to verify if this could be in line or not, and I talked about or requested if they are still working on a copper version, because they told me months ago that this could be an option. They confirmed they are working on it, and I have hope for that, because especially on the desktop CPUs, I mean 11900K, 9900K, whatever, AMD Ryzen CPUs, they have very tiny hotspots. And the base of the Ice Giant is aluminum, which is not the best conductor if you compare it to like very nice copper base. So I guess if they are making a copper version, it could be much better for the desktop CPUs. In the end, it's to me, especially after we cut it open and we saw that there is a lot of structure still inside, a lot of fins also on the top area, it still feels like a massive heat pipe cooler, just with the fact that the entire thing is a heat pipe. It's just a very, very big heat pipe cooler, which can handle overclocked Threadripper CPUs very well. For desktop CPUs, I mean, if you get an NHD 15 and this is like 60 euro cheaper, for any gaming scenario with lighter load, this will definitely be better. This will be a better choice. And for any AIOs, always keep in mind that you're also free to choose the mounting position for the AIO. You can rely on cold air intake, whereas for air cooling units, this could be both for the Noctua and for the ProSiphon, you have to rely on the warmer air inside your case. So there's also something to consider. Okay, was still interesting to me, especially to cut it open, see how it looks inside. That was quite cool actually. So thanks for tuning in, see you next time. Bye bye.